All right, let's talk about the mole. So at the start of this, it says, what's in this mole? And if I asked you to buy a dozen eggs, you would probably say, okay, I've got to go buy 12 eggs. But you probably wouldn't even think that. You would just say, I'm going to go pick up a dozen, because we're so used to that idea that a dozen is this unit that means 12. And another example would be a ream of paper. A ream of paper is usually 500 sheets of paper. So we, as scientists, needed something to describe things that were so tiny, it was just so many to count. So they came up with the mole. And they decided, okay, how about a mole represents 6.02 times 10 to the 23rd atoms. Okay, it's called Avogadro's number. And it's huge. Like the number, if I write it out, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah. This many atoms equals 1 mole. This many of anything equals 1 mole. It's just that atoms are so small, you can hold a mole of them in your hand in most cases. So what we did in this lab was we went around and we measured a sample of these different pure substances, and the sample was a mole's worth. And just for practice, let's write in the symbols here. Iron is Fe, lead is Pb, sulfur is S, aluminum's Al, copper is Cu, tin is Sn, magnesium Mg, zinc Zn, sodium chloride, NaCl. And what we did was we took the mass of the substance that was in a bag. So we have to subtract off the mass of the bag for each of these. So, okay, we've got 56.0 grams, 214.06. It's 1 after the decimal. So I should round this to 207.3. 34.86 minus 2.8. This bag was a little bit smaller. Keeping 1 decimal place here. 33.76 minus 6.8. 27.0 grams. Oops, some of my element symbols are going to get off here. There we go. 70.41 minus 6.8. 63.6, 125.56 minus 6.8, 118.8, 31.07 minus 6.8, 24.3, 72.40 minus 6.8, and salt minus 6.8. 58.5. Okay, there we go. Then what we did was we had everybody enter in their column D numbers so we could get the class average for the substances. And so let's pretend that we did that, but we'll just use ours from here. Okay, now we've got to look up what the average atomic mass is for each of these. So iron is, I'm going to round these to 1 decimal, 55.8. And lead is, I actually have this one memorized, kind of sad. Sulfur, aluminum, I'm sure it's 26.98. So this would round to 27.0. Copper, $63.5. Tin, 118.7. Magnesium, 24.3. Zinc, 63.4 or 65.4. And salt, ooh, that one's not on there. So we'll leave that one blank for now. We'll call it Na. Okay. Based on the information above, what do you think is the relationship between atomic mass and the mass of 1 mole? They're the same. So the mass of 1 mole of a substance is equal to the average atomic mass listed on the periodic table. Okay, what about sodium and chlorine? So sodium on the periodic table is up here, 22.99. And what's the mass of 1 mole of chlorine? Chlorine is 35.45. What was your measured mass of 1 mole of salt? It was 58.5. How does that compare to 1 mole of salt? How does that compare to the mass? How does the mass of 1 mole of salt, compare to the mass of sodium and chlorine? So let's see, what happens if I add these? 22.99 plus 35.45. 58.44, yeah, so it's about the same. They are the same. How do you determine the mass of 1 mole of a compound? You add up the individual molar masses that make up the compound. Okay, so what about for water, H2O? Let's see, we've got 2 H's, so 2 times H is, I've got to look it up, 1.008. And O is, I think it's 15.999. And then let's add those together. So 2.016 plus 15.999. 18.015 is the mass of 1 mole of water. Ooh, sugar. C6H12O6. Carbon is 12.011. So let's do 6 times 12.011. And then we've got 12 times 1.008. That was hydrogens. And oxygen is 6 times 15.999. Now we got to add all these together. 72.066 plus 12.096 plus 95.994. So that would be the mass of 1 mole of sugar. So what does a mole mean in our own words? 1 mole of a substance is equal to the average atomic mass on the periodic table. And it is a unit to represent 6.02 times 10 to the 23rd, something like atoms or molecules. It's easier to say a mole of atoms than it is to say 6.02 times 10 to the 23rd. So it's going to make our lives interesting. Our lives easier. Sorry, I was reading interesting here. Okay, interesting facts about the mole. If you had a mole of rice grains, all the land area of the earth would be covered in rice with a depth of about 75 meters. That's crazy. 1 mole of rice grains is actually more grains than all the grain that has been grown since the beginning of time. If you put a mole of marshmallows over the United States, it would go straight up 650 miles. If Mount St. Helens eruption had released a mole of particles the size of sand grains, the entire state of Washington would have been buried to a depth equal to the height of a 10-story building. And a mole of basketballs would just about fit perfectly into a ball bag the size of the Earth. Crazy. Okay, recap. So we've learned that 1 mole, 6.02 times 10 to the 23rd of something, equals that number. The average atomic mass at the bottom of the squares of the periodic table is also the number of grams 1 mole of that element would weigh. So for example, carbon, if you had 1 mole of carbon atoms, that would be 6.02 times 10 to the 23rd carbon atoms, and they would weigh 12.01 grams. Okay, so what if you had 24.02 grams of carbon? How many moles? Well, 1 mole is 12.01. So how many moles would be 24.02? Okay, so I can do this in my head. It's 2, but it says it wants us to use dimensional analysis. So, okay, 24.02 grams of carbon. We know that 1 mole of carbon is equal to 12.01 grams. Now we multiply across the top and divide by the bottom. So 24.02 times 1 divided by 12.01, that's 2 moles carbon. What if you had 0.04 moles of carbon? Oh, sorry, back to this one. Significant digits would be 2.000 moles carbon. Okay, if I had 0.040 moles of carbon, how many grams is this? Well, we know 1 mole of carbon is equal to 12.01 grams. So now if we multiply this, I'm just going to use one now, 0.04 times 12.01, and then 2 significant digits. So the answer would be 0.48 grams of carbon. Because moles of carbon cancels out, and we've got grams of carbon. Just for fun, how many atoms do you have if you have 0.04 moles of carbon? Well, we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So let's see, 0.040 times 6.02 E23. That's 2 significant digits now. So 2.4 times 10 to the 22nd atoms. Okay, your turn. Dimensional analysis on all of these. Use dimensional analysis. All right, how many moles are in 29.9 grams of lithium? Well, how much does 1 mole of lithium weigh? Let's look it up on the periodic table. 6.94, it says, grams. Multiply across the top. Divide by the bottom. 29.9 divided by 6.94. I'm going to need 3 significant digits. So my answer would be 4.31 moles of lithium. Because grams cancel out. An average sip of water is around 21 grams. How many moles are in that sip? Well, earlier today, we already did how much 1 mole of H2O weighed. It was, we got to go way back here, water. 18.015 grams. Okay, 18.015 grams. So multiply across the top, divide by the bottom. 21 divided by 18.015. Two significant digits. This is 1.2 moles of H2O. When you have a sip of water, do you probably drink more or less than 6.02 times 10 to the 23rd molecules? You definitely drink more. 1.2 moles times 6.02 times 10 to the 23rd molecules in 1 mole. So if you wanted to figure this out, you would do, on OneNote, side over here, 1.2 times 6.02 times 10 to the 23rd. You would have 7.22 times 10 to the 23rd. So 7.2 times 10 to the 23rd molecules. Okay, then let's do the reverse. What's the mass of 0.055 moles of lead? Well, we know 1 mole of lead from the periodic table is 207.2 grams. So we're going to multiply across the top. 0.055 times 207.2. Two significant digits, 11 grams of lead. Convert 1.45 moles of ZnCl2 into grams. First I have to go down here. Zinc, there's just 1 zinc, and the molar mass of zinc is 65.38. And then chlorine, there's 2 of them, and it's 35.45. So 2 times 35.45, 70.9 plus 65.38. So 1 mole of ZnCl2 weighs 136.28 grams. I just added up 1 zinc plus 2 chlorines, their average atomic masses from the periodic table. Now I do multiply across the top. There's nothing on the bottom. So 3 significant digits, 198 would be the final answer here. 198 grams of ZnCl2. Practice makes perfect on these.